So we previously learned that oxygen is an atom that can be classed as highly electronegative. And what that means is that the oxygen atom loves electrons, and so whenever it's sharing electrons with another atom, it doesn't share them very fairly, and it kind of sucks or gathers the electrons towards itself, resulting in polar bonds where electrons aren't evenly spread out, and electron clouds that cause partial charges on the oxygen atom. Now, as it turns out, oxygen is not the only super electronegative element in the list. There are other electronegative elements out there in the universe. Oxygen is one of the most electronegative elements from the list from the periodic table, but we also have fluorine. So fluorine is very electronegative. Oxygen, we already know oxygen. Nitrogen is another highly electronegative element. So is chlorine. And to a certain extent, I'm going to put another one on the list here, sulfur. So fluorine, oxygen, nitrogen, chlorine, and sulfur. These 5 elements could be considered highly electronegative. And what that means is they love electrons and they don't like to share them fairly or evenly when they're being forced to share in a covalent bond. And they always suck the electrons up towards themselves. So let me put the S back. So we have a sort of a rule here that we can kind of bring into play. And we can say that partial charges, that means that little negative cloud or that little positive area, these partial charges occur whenever you find a hydrogen atom covalently bonded to a very electronegative atom. So what we're saying here is that if you find in a structural formula a situation where there's an O, an oxygen atom, covalently bonded to an H, just like I drew there, this bond that I just drew, this is going to be a polar bond, and the electrons are going to be sucked up the bond towards the oxygen. So the electrons are going to spend more time up here, and this is going to be partially negative up here, and this hydrogen is going to be partially positive. So that will happen whether anytime you have a hydrogen stuck to one of these atoms in this list. This bond is the same thing's going to happen in this bond right here. The electrons are going to get sucked from the hydrogen up to the nitrogen. The electrons will end up here, and this will make this partially negative, and that will leave this as partially positive. Whenever a hydrogen is bonded to fluorine, oxygen, nitrogen, chlorine, or sulfur, this is the list. We can say funklux, whatever you want to say it. Whenever you have a hydrogen stuck to one of these atoms in a molecule, then the bond will be polar. There'll be a suckage of electrons towards the electronegative one of the pair, and that atom will end up being partially negatively charged. So you can have you can have pictures of molecules that you don't even know what they are, you've never seen them before, you don't know what they're called, but if you see the structural formula laid out, you should be able to look at that formula and predict whether that substance, whatever it might be, will have partial charges on it. Because if you see an O attached to an H, that's going to be a place where there's going to be a partial negative charge on the O and a partial positive charge on the H. Or if there's an N stuck to an H, you're going to have partial charges with a partial negative on the N and a partial positive on the H again. All right. When you get those partial charges on a molecule and then on another molecule, completely separate, if those molecules come by each other, there's going to be a weak attraction between the partially positive part of this molecule and the partially negative part of the other one. They're going to weakly attract each other, and that will be a hydrogen bond. So in this diagram here, let's look at what's going on here. So up here, what do we recognize going on here? Well, this is water, right? We've seen this multiple times by now. This is our oxygen. and then these are the two hydrogens. All right, those black lines right here represent the covalent bonds that are hooking these things together. And because this is water, we're going to have the electrons sucked up here towards the oxygen and sucked here towards the oxygen, which is going to mean the electrons are going to be making this a little bit negative. And this is going to be a little bit positive over here, and this is going to be a little bit positive over here. All right, so we've put everything we know on this molecule on the top. Like we put up everything we know up here, all right? But there's something else going on down here at the bottom. So what do we see? What can we predict is happening down here? So here's what you should think. First of all, look, there's dotted lines. There's a dotted line right here. That dotted line should tell you in your head, oh, I see a dotted line. That's a hydrogen bond. And you can think, okay, yes, I know a hydrogen bond is a weak attraction. And so if there's a weak attraction between this here and this here, and if the top is partially positive, it's got to be attracted to something that is partially negative, right? We don't know what this blue atom is down here, but we can say, based on what we know from up the top, that it's got to be partially negative. How do atoms in molecules become partially negative? Well, I'm going to direct you over here to this list, right? You get partial charges whenever you get a very electronegative element, F or O or N or Cl or S, attached to hydrogen. So here's a big blue atom of some type that is a little bit negative, and it's being attached by covalent bonds. That's what these black sticks are representing, to three white things. And we know up here, from up here, that the white is H. So we can put H, H, H. All right, if this is partially negative, then the electrons have got to get sucked from somewhere. They're getting sucked from these H's down here. So that means these are going to be partially positive because they've lost their electrons are getting sucked up here. All right, and what could possibly be doing the sucking? It's got to be one of these. So if we didn't know anything about chemistry, you wouldn't be able to go any further with this problem. You'd say this has got to be either F or O or N or Cl or S, but we're not sure. And that would be good enough for most problems, right? I'm going to tell you, just because I know a little bit more about chemistry, and you'll probably learn this along the way too. There's three bonds here going towards this blue atom, and the only one of these that can make three bonds, and only three bonds, is nitrogen, which means this must be N. You know it's got to be one of that list because it's a highly electronegative element, and the ones that are important for biology is that list, and of that list of 5, it's nitrogen. And the reason I knew that it was nitrogen is because it's making 3 bonds, and I know that nitrogen can make 3 bonds. If you didn't know that, that's okay, as long as you knew, you could understand why this had to be F or O or N or Cl or S. All right, I hope that helped you talking through that problem.